So this video is going to show full geometric tolerancing into another bracket and also using profile tolerance in a note. First, let's understand the geometry of what the part looks like. It's a bracket that has some raised up flanges, has some holes put into the flanges and a big hole in the center here. So when I look at all the feature control frames, that sets what the datum reference frame is going to be. ABC, ABC, ABC. So then I find those on the drawing. So A is going to be this back plane here. That's going to create your primary datum. B is your bottom edge here, and C is this left edge. So that creates the datum reference frame in this corner. And look how most of these dimensions are all coming from the datum reference frame, and that makes sense. I didn't want to put a box around every single one of these dimensions. This is basic, and this is basic, and this is basic. Instead, I just had a note here, unless otherwise specified, dimensions are basic. So that makes the 30 degrees basic, the 50 degrees basic. Now, not the size tolerance, because that has plus and minus, that tells you how big and small the hole is. That dimension is not basic, that's determining the size. But all the other locating dimensions are now basic dimensions. So then we use our two big symbols, position and profile, to control your features. So remember, position controls the holes. We float that underneath the size tolerance, so that creates a cylindrical tolerance zone for the hole. Then this position tolerance, those will create cylindrical tolerance zones for these three holes. And in this view here. So now we use profile tolerance, and we directly apply profile tolerance where it matters. So one of the important surfaces was here, profile within 0.2, between points x and y. So we find y here, and we find x here, and it's between those points. Now this is really important to show that arrow again, because there's multiple ways to go from x to y. You can go x to y along this northern route here. We can go x to y around the bottom, or we can do x to y through the middle. And that's why that arrow really clarifies which side of x to y we're controlling from here all the way to here. So that's going to create an offset tolerance zone, half of that 0.1 millimeters on one side and 0.1 millimeters on the other side. Now the actual surface has to be cut inside that tolerance zone. The other surface that's important is this profile right here. So they're applying it to this extension line, which is applying it to this surface. So in 3D, that would be this surface right here. And that's what I like about this. We're pointing to features on the model and applying tolerances there. So this profile tolerance was applied to this surface, where this profile tolerance was applied to this bigger surface. Okay, well, what about all the other surfaces? Well, that's where we can go to a note here. So unless otherwise specified, all surfaces are profiled within half a millimeter. So the surfaces that haven't been controlled are like these surfaces up here. And also this top face, which is going to be in 2D, would be this view, this surface, and that's going to be this surface right here. And those are not important surfaces, so we just have a general profile there. Unless they specified, they're profiled within half a millimeter. This profile tolerance is avoiding what we used to do on drawings. We used to say all dimensions plus or minus. So here we have all dimensions plus or minus 0.25, but we're not doing that anymore. We're not tolerancing dimensions. This is not a dimension-based tolerancing system. It's a feature-based tolerancing system. So tolerancing the surfaces makes more sense. All surfaces have to be plus or minus 0.25, and all the dimensions are basic. So what's the tolerance on this 50? No tolerance. Basic. Now I don't have to put a box around that. That's this basic dimension right here. So instead of tolerancing that dimension, we say this surface has to fall within a profile tolerance of the half a millimeter. And that makes a lot more sense, because when we try to put plus minus on the dimension here, what does that control exactly? Where is the end of that surface allowed to be? And you put plus minus on the angle here, it's really hard to describe what the geometry could really look like. So instead of tolerancing the dimensions and seeing what we end up with, we do it the opposite. We tolerance the feature. We say this surface has a profile tolerance on there half a millimeter, and that surface now can vary plus or minus 0.25 from its ideal surface. Now I want to see if all this makes sense to you with the profile boundaries and the datum reference frame. So the next exercise, we'll do some min-max calculations, more minor stack-ups that you'll have to do to see if you understand the profile boundaries.